Good morning. Myself, Prabharanjay, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is design strategy from the unit 4, that is VLSI testing. From the subject name is VLSI design. Let I discuss. Design strategy in VLSI testing aim to simplify the testing process, improve testability, and ensure that defects are detected efficiently. These strategies are critical to ensuring that a complex chip functions correctly while reducing the cost and effort associated with testing. Design first one is design for test, that means DFT. To design VLSI circuit in such a way that they are easier to test without compromising performance and functionality. Design the chip to increase observability and controllability. If each register could be observed and controlled, test problem reduces to testing combinational logic between register. Better yet, a logic block could enter test mode where they generate test patterns and report the result automatically. And next one is scan test. Scan design. Convert each flip flop to a scan register. Here we have used two mode. First one is normal mode and another one is scan mode. And built-in self-test, embed test generation and response analysis circuits within the chip to allow self-testing without external equipment. uh, Built-in self-test. Here we have three major component. One is TPG, ORA, and BIST controller. Test pattern generator is used to generate the vectors internally, commonly using linear feedback shift register to create pseudo-random patterns. Output response analyzer analyzes the output of the circuit under test and compare it to expected values, often using signature analysis. Sorry, signature analyzer. BIST controller it used to manages the test patterns, that is initial test and analyzing test. And pseudo random sequence, it is a hardware of or a software system that generate a sequence of bits that approximate the properties of a random sequence through its generated deterministically. PRSG, that means pseudo random sequence generator, are widely used in various applications such as cryptography, built-in self-test in VLSI, error detection correction system, and communication system. And linear feedback shift register with input taken from XR or state, pseudo random sequence generator. Here we are using major three component. First one is seed, the initial input values, the starts the sequence generation, changing the seed result in a completely different pseudo random sequence. Next, feedback logic is employed to take the current state of the generator and produce the next state. The feedback typically depends on certain bits of the current state. And another one is shift register, a series of flip-flop that store the state of the sequence generator. This feedback logic alters the content of the shift register to produce the next output. and built-in self-test. Built-in self-test typically consist of a series of flip-flops and some combinational logic that can be conformed into different operational modes based on control signals. This allows built-in logic block observer logic can be to be reused for both generating test patterns and analyzing output. This is the combined scan with pseudo random sequence generator and signal analyzer. And next one is boundary scan. That is boundary scan. The test the interconnect between chips on a printed circuit board and provide mechanism for observing and controlling individual pin of an IC. Boundary scan is accessed through 5 pins, that is test clock and test mode select. Another one is test mode in, test mode out, and test reset. Chips with internal scan chain can access the chains through boundary scan or unified test strategy. Boundary scan is a powerful method for testing, debugging, and programming VLSI circuit and PCBs. And design strategy in VLSI testing ensure that the chip can be tested efficiently for fault and defect during manufacturing and in operation. Techniques like DFT, BAST, boundary scan, and power aware testing enhance test coverage, reduce test cost, and improve the reliability of complex integrated circuit. These strategies allow for efficient detection of fault while minimizing the impact of performance area power consumption of the VLSI system. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.